Hi guys, welcome to my channel Tech Girl. Today we are going to see about analysis of variance using ANOVA testing. ANOVA is a statistics that splits an observed aggregate variable found inside a data set into two parts, systematic factors and random factors. The analysis of variance, ANOVA, is developed by R.A. Fisher in 1920. If the number of samples is more than 2, the C-test and T-test cannot be used. The techniques of variance analysis developed by Fisher is very useful in such cases, and with its help it is possible to study the significance of the difference of mean values of a large number of samples at the same time. ANOVA is a method of analyzing data from designed experiments whose objective is to compare two or more group means. Factorial ANOVA has two independent variables which are crossed with each other. That means each value of one variable is paired with every value of other variable. So we all have a question, why ANOVA instead of multiple t-tests? The answer is, the problem with the multiple t-test approach is that as the number of groups increases, the number of two sample t-test also increases. As the number of tests increases, the probability of making a type 1 error also increases. Hence, we are moving to ANOVA instead of multiple t-tests. So, ANOVA, a single test for multiple comparisons. This is a great advantage of ANOVA. The advantage of ANOVA using ANOVA over multiple t-tests is that ANOVA will identify if any two of the group means are significantly different with a single test. If the significance level is set at 0.05, the probability of a type 1 error for ANOVA is equal to 0.05 regardless of the number of groups being compared. ANOVA, a single test for multiple comparisons, is if the ANOVA f-test is significant, further comparisons can be done to determine which groups have significantly different means. So, let's see about hypothesis in ANOVA. There are two types of hypothesis, null hypothesis and alternative hypothesis. Null hypothesis is nothing but when all the means are equal, we call this as null hypothesis. That is, mu1 is equal to mu2 is equal to mu3 is equal to mu k. So, when all the means are equal, it is null hypothesis. For alternative hypothesis, when at least two of the means are not equal, we call that as alternative hypothesis. That is equal to m1 is not equal to m2, that is equal to m3. For example, the test statistics for ANOVA is the ANOVA F statistics. So let's see about F statistics. ANOVA measures two sources of variations in the data and compares their relative sizes, variation between group and variation within groups. Let's see what is variation between groups. For each data value, look at the difference between its group mean and the overall mean. Variation within groups. For each data value, we look at the difference between that value and the mean of its groups. The ANOVA F statistic is a ratio of the between group variations divided by within group variation. F is equal to variance between the samples divided by variance within the samples. A large F is evidence against null hypothesis since it indicates that there is more difference between groups than within groups. So, we'll see what are the general applications of ANOVA. ANOVA is used in pharmacy, in biology, in microbiology, in agriculture, in statistics, in marketing, in business research, in finance, and in mechanical calculations. So, normally this ANOVA is similar to t-test, more versatile than t-test. ANOVA is the synthesis of several ideas and it is used for multiple purposes. The statistical analysis depends on the design and discussion of ANOVA, therefore includes common statistical designs used in pharmaceutical research. Pharmacokinetic data also will be evaluated using ANOVA. Pharmacodynamics, what drugs does to the body, data also will be analyzed with ANOVA only. That means we can analyze our drug is showing significant pharmacological action or not. Compare the heights of plants with and without galls. Galls are nothing but plant tissues. So compare birth weights of deer in different geographical regions. Compare responses of patients to real medications versus placebo. Compare attention spans of undergraduate students in different programs and programs. Types of ANOVA. There are two types of ANOVA, one-way ANOVA and two-way ANOVA. So let's see the difference between one-way and two-way ANOVA. In one-way ANOVA, one independent variable have been used. In two-way ANOVA, two or more independent variables have been used. In one-way ANOVA, one dependent variables have been used. In two-way ANOVA, two dependent variables have been used. For example, only temperature as independent variable, that is only one temperature is used for one-way ANOVA, but in two-way ANOVA both temperature and concentrations as independent variables have been used. So let's see what is one-way ANOVA. One-way ANOVA. If one-way classification we take into account only one variable, say the effect of different type of fertilizers on a yield. Other factors like difference in soil fertility or the availability of irrigation facilities, etc. are not considered. For one-way classification, we may conduct the experiment through a number of sample studies. Thus, if 4 different fertilizers are being studied, we may have 4 samples of say 10 fields each and conduct the experiments. We will note down the field on each one of the fields of various samples and then with the help of FTEST try to find out if there is a significant difference in the mean yields given by different fertilizers. To calculate variance between samples, calculate the mean of each sample. Then calculate the grand average. Take the difference between mean of various samples and grand average. Square these deviations and obtain total, which will give you sum of squares between samples, that is SSE. Divide the total obtained in step 4 by the degree of freedom to calculate the mean sum of the square between samples. This will be very clear when we work out an example. So this is about mean sum of squares, that is equal to SSE divided by k minus 1. K is nothing but number of samples. Then to find mean sum of squares within samples, that is equal to SSE divided by n minus k. N is nothing but total number of observations and k is the number of samples. So to get the mean sum of squares, we are using these formulas. Calculating variance within samples. Calculate mean value of the sample and do the same thing as explains in the example. So let's say with an example, samples obtained from normal populations with equal variance. Test the hypothesis that sample means are equal. This is a question. So these are the steps to be followed. Let's first check whether it is a null hypothesis. So for a null hypothesis, we already told that all the means should be equal. So let's check that. Then we'll see about state alpha, that is equal to 0.05. Then calculate degrees of freedom, that is equal to k minus 1 and n minus k. That will be 2 and 12. State decision rule table value of f and at 5 percentage level of significance, and f should be greater than 3.88. So if these are all possible or not possible, we'll check with the calculations. So this is of null hypothesis will be rejected if f is greater than 3.88. Calculate test statistics. It's like we are taking values x1, x2, x3 and we are calculating, we are adding x1 values and totaling it, and we are taking a mean value from that, and all the means of m1, m2, m3, that is equal to x1 and x2, x3 means are added for a grand average, and we are dividing that with 3 and we will be able to get an answer. Variance between samples. To calculate variance between samples, we are moving with a formula of SSE, which we have already seen. So MSE, we are substituting SSE divided by k minus 1, which is equal to 20. So variance within samples, that is equal to m1 is equal to 10, m2 is equal to 8, m3 is equal to 12. Sum of squares within samples is equal to 30 plus 16 plus 14 is equal to 60. So MSE is equal to 60 divided by 12 is equal to 5. Calculation of ratio f. F is equal to variability between groups divided by variability within groups. So f statistics is equal to MSE divided by MSE. That is equal to 20 by 5, which we have already obtained. That is equal to 4. So this is a shortcut method, very easy to do, one-way ANOVA. So I have also explained the steps of shortcut methods. You can refer to this calculations which we have already done. This is a very shortcut method, so you can easily do. So now we will see about two-way ANOVA. So what is a two-way ANOVA? When two independent variables, that is nominal or categorical, have an effect on one dependent variable, ordinal or ratio measurement scale, compares relative influences on dependent variables, examine interactions between independent variables. Just as we had sums of squares and mean squares in one-way ANOVA, we have the same in two-way ANOVA. Include test of three null hypotheses. Means of observations grouped by one factor are same. Means of observations grouped by the other factors are the same. There is no interaction between the two factors. The interaction test tells whether the effects of one factor depends on the other factor. So let's see with an example. We have test scores of boys and girls in age group of 10 years, 11 years and 12 years. If you want to study the effect of gender and age on score, two independent factors, gender and age, has been taken. Dependent factors are nothing but test score, because we are calculating all other things depending on test score. So test score is a dependent factor. So what is the null hypothesis? Let's see. Null hypothesis: gender will have no significant effects on students. Same way, age will have no significant effects on students' score. Gender and age interactions will have no significant effect on students' score. So to calculate, let's take source of variations, degree of freedom, sum of squares, mean squares, F ratio and P values. And these are the formulas to be used to calculate. So this is easy to calculate, same like one-way ANOVA. This is another example for you to work out this two-way ANOVA. I'll just explain the question. Do people with private health insurance visit their physician more frequently than people with no insurance or other type of insurance? Let's take n is equal to 86. Type of insurance are like no insurance, private insurance and TRICARE. Number of visits to their physician, dependent variable. So you can calculate like which I have done in above example. So we have discussed about one-way ANOVA and two-way ANOVA, and we have seen with an examples. There is nothing but these are two types of ANOVA. So we have seen all about ANOVA. This is all about ANOVA. To see more videos, do subscribe my channel Tech Girl. Thank you.